take a few minutes. It's not that bad as it looks, okay? But what I want to talk about, the reason I want to talk about this problem is because one of the most important applications of the instantaneous rate of change, or the derivative, or the slope of the tangent line, is for projectile motion problems. And so note, I wrote this on here. If S of t in this equation represents the displacement of an object at any time, right? Then the instantaneous rate of change with respect to time S prime of t represents the velocity at any given time. So if you know, like for instance, the time at which, so say you know the equation of, okay, Aaron, start again. So for instance, say you want to know all of these things. What is the instantaneous speed of the ball at the start when it's launched? What is the instantaneous rate of change of the ball at time t equals 2? When is the instantaneous speed of the ball equal to 0? When is the instantaneous speed of the ball? What is it when it passes a rooftop? Okay, et cetera, et cetera. You can answer all those questions with the equation of the derivative. So the first couple, where'd that go? Oh, there it went. So the first couple problems just deal with plugging into this formula. When does the ball strike the ground? So this is displacement. So if I want to figure out in this particular problem when the ball struck the ground, what would be the displacement when the ball strikes the ground? 0, right? So you just set this equation equal to 0, and again, negative 16 t squared plus 80t plus 96. And what's nice about this 96, 16 goes into all these numbers, okay? And you get, or if I divide away a negative 16, which is even better, I'm going to divide both sides by negative 16, okay? Because I'm allowed to do that, right? And when I divide everything by negative 16, I get t squared minus 5t minus 6 equals 0, which is very convenient because that factors. And you get t equals negative 6, or that's a negative 6. Can you see that? Or t equals t plus 1, okay? Which means it hits the ground at t equals 6, because t equals negative 1, you throw away, because you're not talking about negative seconds, okay? So basically what's happening here, just to draw kind of a picture of the situation, here's the top of a roof. Someone,
your 6 was negative, your 1 was positive.
yeah, but but I'm setting it equal to 0, right? So what's going to make t equal, what's going to make t minus 1, t minus 6 equals 0? T is equal to 6, right? So, so t is 6, right? So not negative 1. And what this corresponds to, someone throws a ball off a roof, it goes up, and it comes down, okay? Except it's really going straight up and straight down, but along this axis you have time. So if I were to graph this versus time, I would get a parabola that looks like that, okay? At what time will the ball pass the rooftop on its way down? Well, you know that the rooftop is 96 feet. So what you do is you say that when will it be 96 feet high? So you go 96 equals, yeah, okay. Logan, I can't think with you talking in my ear. Here. 96 equals, negative 16 t squared, right? Plus 80t plus 96, right? And then these go away. Yes? And now I can factor out a negative 16 again. Negative 16, I could actually factor out a negative 16t times t plus minus 5, right? Minus 5, okay? And I set that equals 0, because I cancel these out, which makes this side 0, right? And then I factor it out. So then you can factor this here. So either t equals 0 or t equals 5, right? And this corresponds to where it starts, of course. And this corresponds to the time at which it goes up and then it comes down and is even with the ceiling again, even with the top of the roof, right? All right, so these things, remember these. 5 seconds 6 seconds, because then you use that to remember to solve the rest of the problem. Okay? So at 6 seconds, the ball will hit the ground, and at 5 seconds, the ball will be even with the top of the rooftop here. So now we got to go and we got to do the hard part, okay? Which is when is the instantaneous rate of change of the ball? T equals 0. So what you need to do is take the limit of this function. So this is the limit as x, as x, no, not as x, as h goes to 0. H goes to 0 of f of x plus h, f of x plus, or it's s of x plus h, which I'm gonna call now. So I gotta look at my notes, and I'm not gonna do the whole thing. I'll leave it as an exercise to the student. So what you get, you're going to get the limit of negative 16 times t plus h squared. T plus h quantity squared. Okay? Plus 80 times t plus h. Okay? Plus 96 minus, in parentheses, s of t, which is negative 16t squared plus 80t minus 96. Okay? Over this whole thing over h. Okay?
It should be plus 96.
Plus 96, sorry. Okay? Plus 96. And then what happens here is you FOIL this out. Just actually, what I would do first is factor out the, you can take out a 16 from everything, okay? And eventually what you get down to is the limit. I'm not going to do the whole thing, okay? Because it's too long, okay? The limit as h goes to 0. It's really what we did in the last problem. And this squishes down to negative 32 ht minus 16h squared, 16h squared plus 80h plus 80h over h, right? I think some of you have this. Don't you? You get that? What's that?
ADHD.
ADHD.
I thought that was 80 for.
I just So anyway, then what you can do is cancel out an h from everything, okay? And this becomes a 1h, and this goes away. And what you end up with the limit, sorry it's so messy, you end up with the limits as h goes to 0. And this just comes out of, if you multiply this out, you cancel things that cancel out, that works. You end up with the limit as h goes to 0 of negative 32t minus 16h plus 80, right? And you take the limit as h goes to 0, and you're left with negative 32t plus 80, right? And what that is, that's the derivative s prime of t. That's the rate of change at any point. So this equation will give you the velocity of the projectile at any point. So it says, what is instantaneous speed of the ball at 2? So you just plug in 2 in there, right? And you get out negative 64 plus 80, which gives you, hello, 16. And that's in feet per second, okay? Feet per second. And then the next question says, when is instantaneous speed of the ball? 0. So what do you think I do with that rate of change? set that equal to 0, and you get that negative 32t equals negative 80. And if I divide negative 80 by negative 32, I think I get t is equal to 2.5 seconds, I think. Don't I? Yeah, I do. Okay, so that corresponds to, way up here, let's see if I can go back. Can I go back? That corresponds to this point, right? When is the velocity equal to 0? After 2.5 seconds, it's here, right? And that kind of makes sense because that's halfway between here. Remember what time this was?
5.
That was 5 seconds, and this is 0 seconds, so halfway in between is 2.5. So you can figure out when it turns and comes back, right? Okay, going back.
So if you put 6 seconds on the test, you would not get it right.
If you put 6, oh yeah, because when it hits the ground, it's really not going 0. It's after, Yeah, I understand what you're saying.
6.1.
Yeah, 6.1, I guess it's 0, but that's not really what they're asking.
Is this going to be on a test?
I think I'm going to put something like this on the yeah, it's going to be exactly the same problem. Okay.
This one, right?
Yeah, but I'll change the numbers.
No, you won't.
Okay. Yeah. Okay. So then going down, it says I don't know how to get rid of this. What is instantaneous rate of change as it passes the ball on the way down, as it passes the roof? Remember from before, that was 5 seconds, right? So I plug in 5 in there, yes? And I get negative 32 times 5, which is negative 160, is that right? 160 plus 80, which is negative 80. And you might say you can't have negative feet per second, but you can if it's going downhill. Velocity, the sign matters, okay? Speed is just the absolute value of velocity. But with velocity, if it's negative, it's coming down, okay? And then it asks you the next question. I don't know how to navigate this page, but the next question asks you, what is instantaneous rate of change when it hits the ground? So you just plug in, you're going to get s prime of 6, right? You plug in 6 into the equation. What was the equation again? Negative 32t plus 80? Plus 80. And if I plug in 6 in there, or I get out negative 192, all right? 192 plus 80. So when it hits the ground, it's going negative 112 feet per second. Yes? Okay? And then the original question, when is it equal to 0? Or what is the speed when it takes off? T sub 0. What would that be? T sub 0. If I plug in 0 in here, what do I get out? 80, right? So the initial speed is 80, and that was somewhere in the original equation, wasn't it? Okay? If you look back, okay? If you look back when it was equal to 0, there's the initial velocity, right? This is the initial height, and so on and so forth. Okay? So you just have one problem on your homework like that.
That has like the whole alphabet in there.
That's about it.